let's talk about breadboards. If you go to Components, All in TinkerCAD Circuits and scroll down, you will find a couple of breadboards to choose from. This is the mini breadboard, the small breadboard, and this one is just called breadboard. The large one is basically two small ones sitting next to each other. And the mini is like if you took out just kind of this middle section and only used it. I'm not going to keep that one out or the big one out because this one, the breadboard small, is the one that is most similar to the one that comes in your kit. And so this is the one that I want us to look at. If you zoom in, you can see that it has a plus row and a minus row, and on both the top and the bottom, and these kind of shorter linked sections inside. What a breadboard is going to allow us to do is to link up components without having to actually solder them together. And while that may not be a big deal in a simulation, because you can just kind of click to connect two things, that's not how it works kind of when we use real components. So we like to be able to click them into a breadboard and try things out without having to make them permanent. So we're going to look real quick at what's going on inside a breadboard. So under here, there are these little rails that look like this. Because metal is conductive, this rail is completely connected to itself. Any metal that we clipped on or clamped in here would be connected to the whole rail and everything else attached to it. So this is what happens when you plug a piece of a component into that rail. It goes down in between kind of those metal teeth right there and is now electrically connected to this whole rail. Those rails exist inside your breadboard. There are two long ones on the top and bottom, and two long ones on the top and two long ones on the bottom, kind of running the whole distance. And there are these little short bars that are these blue lines in between. So if your board looks like this one on the left, if you were to turn it over and peel off the back, you would be able to see the short little bars all through the middle there, and the long bars on the sides. So back to TinkerCAD. What does that really mean? TinkerCAD does a good job of highlighting and kind of demonstrating this. When I hover over any of the holes in this very top row, you can see how it lights up all the other holes in the top row as well. Same thing here, all the other ones in this row and on the bottom. But in the middle, instead of this long row, you get this short section, right? So this short section is where a bar exists underneath this plastic top. Anything I plug in to right here, where this little red spot is, will be connected to anything I plug into this one, this one, this one, or this one. These 5 holes right in a row. They will not be connected to anything in the row next to it, either to the right or to the left. They will also not be connected to the matching row on the other side of the gutter. Nothing is connected across the gutter here, down the middle. The numbers on the rows and the letters across the top don't signify anything other than a good way to communicate to someone you're trying to explain to where to plug something in. So that if I say plug something in to G5, I can follow the coordinates and find G5 and know that that's where I should be plugging something in. So why is this useful? What does it all mean? So I would like to recreate this battery and LED circuit I made right here using the breadboard to connect instead of this pretend soldering situation. So I'm going to go get the same components, an LED, a resistor, and a battery. When I zoom in, you can see that the LED will line up and kind of click into two adjacent rows. So this means that for this anode, everything, these 4 dots below it, anything I plug in there will be connected to that spot. And on this cathode side, anything in these 4 dots will be connected to that cathode side. For the resistor, if I plugged it in here, I wouldn't be making much progress. I would just be connecting the resistor to itself, right? And nothing else. That's not what we want. Instead, I'm actually going to connect it across the gutter here. So now this anode is connected to one side of the resistor. The other side of the resistor is connected to everything in this little section right here, these 5 spots. Okay, so far so good, but we're going to need some power. We know that we want this anode leg to connect to the positive side of the battery, and it's going to do that through the resistor. So I'm going to take a wire from here and connect down to the bottom of the resistor. This leg of the LED we want connected to the negative side of the battery. I am going to go maybe down and around and share with the negative side of the LED. Okay, so if I've connected it all correctly, when I start the simulation, our LED should light up. And it does. Now, if our circuit is this simple, it is fine to stop right here and have that be connected enough. But as our circuits get more complicated, we might want more than one thing connecting back to this battery. And that is where these power rails come in, and they're really handy. So if I take this positive on the battery and connect it to the positive rail on the breadboard, and this negative on the battery and the negative on the breadboard, now I can connect anywhere along this whole stripe and it will work just the same. So if I know I want this to connect to positive, I could connect to positive right there. And if I know I want this to connect to negative, any one of these spots, I could connect negative way over here, and it should work just the same. And it does. My LED turns on. So while this is perhaps an extra step right now, it's good practice to be in as we move forward, because when you want to connect multiple things to your power source, this will make it a lot easier.